Today, we are diving into a really clever engineering pattern. Seriously, it solves a huge problem for some of the biggest and most established cryptocurrencies out there. We're talking about how to teach old legacy tokens some very impressive new tricks, all without changing a single thing about them. It sounds kind of impossible, right? Well, let's get into it.
So, to kick things off, let's start with a problem that's not science fiction anymore. It's right around the corner. We've got AI agents, automated systems, things that need to use and pay for services online. But how are they supposed to do that? An AI can't exactly whip out a credit card or scan a QR code at checkout.
And this is where a really cool protocol called X402 comes into play. It's this brilliant idea that basically embeds crypto payments right inside an API request. It's super fast, it's efficient, and it is absolutely perfect for a future where machines need to pay other machines for stuff instantly.
But, and this is a big but, there is a huge catch. For X402 to work its magic, it needs modern tokens. Specifically, it needs tokens that can handle something called gasless payments. That's just a fancy way of saying a third party, like the service you're trying to use, can pay the network transaction fees, the gas, for you. It makes the whole experience seamless.
And that brings us right to the heart of the problem. What happens when these old, established tokens, the ones everyone already owns and uses, just can't pay the new way? We're going to use a real-world token, XNY, as our case study today, because its story perfectly illustrates this exact challenge. It ran headfirst into this wall, this protocol problem, and that forced its community to hunt for a much better solution.
So here's the critical difference. You've got your modern tokens, built with standards like ERC-3009, and they have all these cool gasless features baked right in. But then you have most tokens, including our friend XNY, which are legacy tokens. They're built on the classic rock-solid ERC-20 standard, which is great, but they just don't have this new functionality. That makes them completely incompatible with something like X402. And check this out. This isn't just some small niche issue. This is a massive, ecosystem-wide challenge. A staggering 95% of tokens on a major chain like Ethereum are these classic legacy types. And those modern ones that X402 needs, they make up a tiny fraction. So the problem is huge.
Okay, so the puzzle is clear, right? How do you get these billions and billions of dollars in legacy tokens to play nice with all this cutting-edge new tech? Well, let's walk through the usual solutions people try, and you'll see pretty quickly why each one is kind of a painful compromise. All right, option A, the most obvious idea, right? Let's just start over. You create a brand new, updated version of the token. We'll call it XNY version 2. It's got all the modern features included from day one. Problem solved?
Not so fast. This is actually a nightmare in practice. You completely fracture the ecosystem. Every exchange, every wallet, every protocol now has to support this new thing. It costs a fortune to move all the trading liquidity over, and it creates a terrible user experience. You're forcing everyone to manually swap their old tokens for new ones. Honestly, it's an absolute last resort.
Okay, so reissuing is out. What if we could just, I don't know, update the original token contract? You know, kind of like pushing a software update to your phone, but for the token to add the new features.
Well, for a token like XNY, that's a complete dead end. Its contract is non-upgradable, and this isn't a bug, it's a feature. The whole Web3 world is built on this idea of immutability, the idea that the rules can't be changed after you launch. It's what gives users trust and security. So this path isn't just blocked, it kind of goes against a core principle of the whole space.
So that brings us to the third common pattern, something called wrapping. The idea is you create a new smart contract where people can lock up their old $XNY tokens. In return, the contract mints them an equal amount of a new, feature-rich version, maybe called wrapped XNY or WXNY.
Now, this works technically. We see it all the time with things like wrapped ETH. But it brings its own set of headaches. You suddenly have two different assets floating around, the original and the wrapped one. This splits liquidity, it creates a ton of confusion for users and developers, and it just adds this whole extra layer of complexity that kind of defeats the goal of making things seamless. So as you can see laid out here, none of the standard solutions are perfect. Not even close. Reissuing and upgrading get rid of the original token. Wrapping keeps the original, but it adds a confusing second one. Every single option comes with a major, painful trade-off.
This whole mess, this deadlock, forces us to step back and ask a much better, much more elegant question. What if we could add all these cool new features without touching the original token contract at all. And that question changes everything. It completely reframes the problem. The focus shifts from trying to change the asset itself to just adding a new capability layer right on top of it. This little shift in perspective is what opens the door to a way better solution.
And that solution is the Gasless Adapter. It's a separate, standalone contract that basically acts like an interpreter or a translator. It sits alongside the old token, and it gives it all the modern features it's missing without ever modifying the original.
Here's a really simple way to think about it. Imagine the original token contract is like an old-fashioned bank branch. It's super secure, but it only accepts in-person requests. Now the Gasless Adapter? That's like a brand new, modern check clearing service. It doesn't hold any of your money itself. All it does is validate your signature on a check, and then it goes to that old-fashioned bank branch and makes the in-person request on your behalf.
So let's look at the technical flow. It's actually pretty straightforward. First, a user does a one-time transaction to approve the adapter to manage their tokens. That's it. From then on, to make a payment, the user just signs a message offline. No transaction, no gas fee for them. A service, called a relayer, takes that signature, submits it to the adapter, and pays the gas. The adapter checks that the signature is legit, and only then does it tell the original token to make the transfer. Boom, you've got a gasless experience.
So we've seen the problem, we've gone through that whole gauntlet of flawed fixes, and we've landed on this incredibly elegant solution. So let's just zoom out for a second. What is the real impact here? Because this isn't just some clever piece of code. This is a genuine bridge to the future, and it's worth understanding why.
The advantages are just massive. The original asset stays completely untouched, pure. There's no second token, no split liquidity, no confusing the heck out of your users. And the best part? This pattern can be used for any classic ERC-20 token out there, creating a reusable piece of infrastructure for the entire ecosystem. It's a win-win-win.
At a deeper level, what this is really doing is resolving a core tension in the blockchain world. On one hand, you have assets that need to be stable and predictable for years to come. On the other hand, you have protocols that need to constantly evolve and innovate. The adapter creates this beautiful middle path, a translation layer that lets the old participate in the new without being destroyed.
And that, right there, is probably the most profound takeaway. The Gasless Adapter is this powerful pattern that honors one of Web3's most sacred principles, immutability, while at the same time preventing stagnation. It lets us build the future without having to tear down the past.
Which of course leaves us with a really fascinating final thought. This idea of a non-invasive capability layer is just so powerful. So if we think beyond just tokens, what other legacy systems, what other unupgradable contracts or protocols out there could we evolve using this same brilliant adapter pattern?